Hello. Hi. This is Naveen from MTech BIT College, Bangalore. As now we are going to study about case studies with Python programming and Django framework on noise pollution monitoring system. As you know, the noise pollution is growing concern in an urban area. In this noise pollution, it will be monitoring. We will be monitoring noise levels, and which can help in environmental planning and public health. And this case study uses Python and Django framework to develop an web-based noise pollution monitoring system. In this, we have in this noise pollution monitoring system, we will be dealing with our else we will be studying about these like introduction, objects, system architecture, implementation steps, and Django framework using Python code for noise pollution monitoring system. As we know that noise pollution monitoring system in using Django like a Django framework and also Python, it can help for building the web-based systems to collect the data, to analyze the data which we have been collected, and also visualize the data for pollution, visualizing the noise pollution data. And it can be structured approach. Will be including key components. In this, we'll be studying the key components and some Python programming using Django. This noise pollution is a major concern as we know that in an urban areas which can be affect the public health and also environmental quality. In noise pollution monitoring system, it will be help in the tracking noise levels and analyze the trends and also provide insights for the mitigation effects. This study explores the development of Django based web applications that collects and process noise pollution data. In this introduction we have an four types like we were gonna study urban noise pollution and also role of monitoring, IoT based monitoring and data collection and storage of these noise pollution. In these urban noise pollutions, due to these urban developments, noise levels in cities have increased significantly, causing health hazards like sleep disturbance and also stress for the public or the persons who have been affected by these noise pollutions. Noise pollution mostly occur in the urban areas because there we have been more number of vehicles and more number of for the main thing is that main thing occurs from this urban area is like vehicles. We have in more number of vehicles in these urban areas, and it will be through more number these bunch of vehicles will be through these we will be causing the noise pollution. Affecting from these noise pollution, the person get sleep disturbance and also stress. In this role of monitoring, we'll be monitoring the noise pollution, which can help in which can help in creating urban noise maps, which assist policymakers in controlling noise level around the residential areas and schools and parks, etc. And now we're gonna study about IoT based monitoring. This IoT based monitoring in this noise pollution monitoring systems uses IoT based noise pollution monitoring systems will be using the IoT based noise monitoring stations, which will be placed at the different city location where the noise pollution occurs in the urban areas, like in the traffic lights near there will be placing these monitoring noise monitoring stations in the localities. And by these monitoring stations we will be collecting some data and we'll be storing the data in the cloud platform or a server. on servers, and then we will be aggregating to generate the noise maps. Through this, we have in some cases like a noise mapping study shows in city experiences serves noise pollution. A smartphone applications was designed to allow users to measure and report noise level to an central servers, etc. Like now we're gonna do with the objectives. In this objectives, we have an web-based system and collect noise data, data visualization, and also alerts and reports. In this web-based system, we gonna develop or create or implement an web-based application using these Python and then Django framework, Django for noise monitoring. We'll be creating an or we'll be developing an application like a web-based application for noise monitoring, and also we'll be collecting by developing a web-based application, we'll be monitoring the noise pollution. Through this monitoring, we'll be collecting the noise data, real-time noise data, noise level data from IoT sensors which we have been placed in the urban areas or city localities, that noise monitoring stations. Through those stations, we will be collecting their real-time noise level data, and through that we'll be taking the inputs, and we'll be providing the data visualization using graphs and heat maps. Finally, we'll be implementing the alerts and reports for the high noise levels. Okay. These are the objectives of these noise pollution. These are the objectives of these noise pollution monitoring systems. And we come across like systems like system architecture. In this system architecture, we have in components like we are gonna deal with components like a front end, back end, database, data collection, data visualization. For front end, we will be for this noise pollution front end, we will be using like HTML, CSS, JavaScripts. These are the some your user interface booster for user interfaces, or these are the say, implementation steps like for a front end. To develop an front end we need and these frameworks like HTML web application, CSS, which will be used to form the front end of these projects, and JavaScripts also. And for backend purpose we'll be using Django, like a Python code, Django or REST frameworks for API development. And also for database collection, we'll be using like Postgres SQL or SQLite. For data collection through IoT sensors like Arduino with sound level meters, like or manual CSV upload. From IoT sensors, we will be getting the data, or we'll be collecting the data through these sensors like Arduino with sound level meters. And also by after collecting these data, we will be visualizing through matplotlib, chart.js, and plotly. These are the some architectures for noise pollution monitoring systems. These front end is the main important things for the these organization front end, back end, database. Through these data collection, we are collecting the data from IoT sensors, and we will be visualizing through the by using the matplotlib and charted and etc. Now we have an implementation steps. How we gonna implement these steps like using the Django framework by Python code. We have certain steps like we have 6 steps like set up the Django project. We'll be setting the Django project by using the Python code and defining the models for storing the noise data, which we haven't collected from the IoT sensors, or like stations, monitoring stations, which we placed in the urban cities. Through this, we will be storing the data in the SQL database. In the database, for this we will be defining the models for storing the noise data. And after these, we will be creating views for each of views to fetch and display the data. For each model, we will be having creating the views In this step, and further we will be defining URLs and routings. And fifth step, we will be doing design templates for dashboard and charts. And next we will gonna run the Django server and test the systems. As we said that implementation steps, we have in setting the Django framework. This Django framework, we have an code in a Python code. Django framework using Python code for noise noise pollution monitoring system. In this Django framework, we have an code. We in this in implementation steps, we have seen that we have an setting the Django framework. First, we need to set the Django framework like a admin, Django admin as a start project noise monitoring. And see, and also this the Django project is for monitoring the noise levels at different locations. Now we'll be breaking down it by step. And also Django admin now project creating the Django project named as we'll be creating Django admin for project named as noise monitor. We'll be navigating into the in this we'll be navigating into the project directory and creating a Django app called monitoring. We'll be creating a Django app called as the monitoring. And now we will be building the model from will now we will be building the models Django for the noise data from Django.db import models. Noise data model stores location. It will be storing the in this location a string of maximum length of 255. It represents it represents the place where the noise was recorded. And in this noise level is equals to model dot float field. It will describe that a floating point number for a noise intensity in the disables. And also timestamp. In this timestamp is equals to model dot date time field auto now add is equals to true. In this timestamp, a date time field that automatically saves the current time when a record is created. We are gonna string define string self. We're gonna define the string string method returns and the reliable string format of an object. Now, from Django shortcuts import render from model dot import noise data. We're gonna define noise data. Mm, we're gonna define a noise dashboard request it will views. It is an view. We'll be creating a view for noise data dashboard, fetching the latest 10. We'll be in the ERC noise data is equal to noise data dot object dot all dot order underscore by minus stamp of square bracket dot action. This implements that it's in a 10 10 implements that it will be fetching. We will be fetching the latest 10 noise recorded. We'll be taking 10 samples or records from the noise data ordered by a timestamp in descending order. Next, passes this will be passing these data to the monitoring dashboard.html template for render. And finally we will be URL finally we will be URL patterns configure. Now we will be configuration. We will be doing URL configuration. It will be map the root URL to the noise. So it will map the root URL to the noise dashboard view which have been created. And also mm, totally we in this Django framework, this Django app records noise level like briefly we'll be telling briefly in the sense in this briefly we'll be telling this Django app records noise level at the different locations. The model stores locations noise level in dB data dashboards and the timestamps. This views fetches and displays the latest 10 noise records, and the URL mapping connects the dashboard view to the root URL. Now we're gonna discuss about the HTML, how we're gonna implement this HTML like front end for this noise pollution monitoring system. The HTML code is for the noise pollution monitoring system dashboard that displays an chat using the chat.js chat.js to visualize the noise level, over time. In this, in this HTML, we will be describing HTML5 documents like the title sets, will be setting the title as noise pollution monitoring, and also we will be including some chat JS from JS developers CDN to create the chat. To create the chat, we will be including these chat.js and from JS developers to create JS developers CDN to create the chat. Now dashboard heading is the canvas for the chart like displaying head. Now in this will be displaying head H2, heading as H2, like creating an canvas ID as a noise chart where the line chart will be drawn, where the line chart will be drawn in this line, and also like JavaScript for the chat JS like where CTX is going to document out get line. Now, yeah. In this where chart is equals to new character, it will define a new line character using the chat. It will define or it will create a new line by using the chat.js as a mm, as label dot percentage for data in noise underscore data percentage data dot timestamp and percentage and for it implies that it extracts the time stamps from the Django noise data and it adds them as an label on the x-axis. It will extract the noise level and adds the it will extract these third step like or data from noise data percentage. It will extract the noise level and add them to the y-axis. This will extract the timestamp from the Django noise data and it will add them to the x-axis. This line will extract the noise level and adds them to the y-axis. Now we'll be customizing the chart appearance. We'll be customizing this board border color that red. The border line is this border color will be implements that the line is red in color and the area below the line is not filled. So we have in filled is equal to false. Yeah, for fill is equal to fill false in the sense like this area below the line is not at all filled. Okay. Now, overview of this HTML code is that fetching noise data from Django and embeds it into JavaScript and generating the real-time noise level graph by using the chat.js as previous slide we have discussed and visualizing the noise levels over a time in an interactive live chats. And like in this, we'll be adding in the future, we'll be adding real-time updates with an AJAX and improving styling using CSS and add data filtering to the view noise level over a specific time ranges. And in this conclusion, we will be like this Django based noise pollution monitoring will be helps like authorities and research tracks we will be tracking the data or tracking the noise level through these like through as we yeah yeah as we discussed in the first slide, like we'll be tracking the noise from the stations, like monitoring stations, and also we'll be analyzing those data. By tracking those data, we will be collecting some data from the IoT sensors, and we'll be storing these data in the servers of the or in the cloud platform. And we'll be storing that, and we will be analyzing and taking actions and taking actions on those data and against high noise pollution levels. And it can be extended by integrating machine learning for the predictive analysis and IoT sensors for real-time data collections. Now, we haven't seen like Python code. Now we'll be working in the Arduino board by implementing some code, and also we'll be working with an artworks for implementing for against and taking action like a high level noise pollution level. So using the hardware parts in this. Okay. Now we are gonna go with what we'll be explaining in the Arduino board for like taking hardware parts. Yeah. Yeah. Mm, yeah. This is the overview of noise pollution monitoring system. This is the like circuit diagram, circuit or an in Tinkercad we gonna do the no we gonna detect the noise from these yeah, potentiometer. We in this hardware parts we have an potentiometer and also two LEDs, two LEDs. It is red and green, and we have an Arduino board, and we have we have an LCD 16 into 16 into 2 thing, and also we have an piezo, and we have an resistor. We have an three resistors and Arduino board, Arduino Uno R3, and one breadboard and one web breadboard. From this we have an connections to the Arduino board to LCD 16 into 2 and to the Arduino board, and it is connected to the breadboard, and breadboard to the there's LED lights which is connected to the register. Through register we have connected to Arduino board, and also another LED light which is connected for the register and also for the breadboard. Through this potential meter, so we can detect the noise. We can detect the noise by like we have a code for these to run these hardware part like these system. To run these code we have an Arduino board, like we have an code like yeah, this is an C code, C language code to run these to run this. Like we have an like into red LED as we implemented in this hardware part, red LED, green LED, and one buzzer and sensor, one sensor. It is potentiometer in the sense it is a buzzer and sensor, and also sensor thrust, and we have an wires plug-in wires and wire setup, that ping mode, red light output, and red green LED output, and also like green LED and buzzer, sensor, buzzer, and ping mode like a sensor. In this, we will be taking input as in sensors to detect the noise pollution, noise is present or no. Okay, and we have a loop. We're gonna take loops, and else we'll be dealing. And this is an overview of this code, and this we're gonna. Mm, yeah. These like first line hash include liquid crystal dot h. This imports the liquid crystal library to control these. control the 16 into 2 LCD display. Okay, it will be controlling the 16 into 2 LCD display, which can be imports the liquid crystal library. So we will be importing the crystal liquid crystal .hl to control the LCD, the 16 into 2 LCD display. And by initializing these liquid crystal LCD, that is, it pings used for the and these arguments like 5, 6, 8, 9, 10, 11. It's corresponding to the Arduino digital pin connected to the LCD. And as we know, the red LED indicates the high noise, and yellow, green LED, which will be indicating the noise, which is have been safe or safe noise level, and buzzer, which activates when noise is too high. So we will be using buzzer, which will be indicating that, and sensors indicates that analog sound sensor and AO pin, and sensor threshold, noise threshold values. If the noise sensor reads a value above this, an alert is triggered, like 600, above 600, like then we will be setting some functions like void setup, ping moderate, configures LEDs, buzzer sensor as an input and output. Here red light will be like red light, green light, and buzzers will be the output, and sensors it will take as an input. And this start serial communication at it will start serial communication at like 9600, and uh, for debugging, and initializes the 16 into 2 LCD displays, 16 into 2 LCD displays, and we have a loop functions like it is a main logic for these noise pollution monitoring system hardware part. Like we're gonna read the noise level from the sensors, analog read sensors. From this analog read sensor, we're gonna read the noise level from the sensors, and print the noise level in the series monitor for debugging. If noise level is high, if the noise level is high above threshold, we haven't kept the threshold value as an here 9600. It is an threshold value as an uh, mm. And if noise level is high, above than the threshold value, the red light turns on. If it is below or less than the threshold value, it shows the LED, like a green LED turns off, and red, it is like, as we, if the threshold value, the noise level is high, the above threshold value, above then the noise level is above than the threshold value, the LED will be on and green LED will be off. If the noise level is below than the threshold value, the green LED will be on and red LED will be off. Buzzer sounds at 1,000 hazards for 500 meters. LCD displays alert. In this LCD, that 16 into 2, it will displays like alert, high noise, and noise levels. When it is in red light displays, the as it is the LC in the LCD displays that alert noise, high noise. It will be alerting. It's indicates that high noise and noise level. Wait 1 second and then update the noise level on the LCD. Next, if noise is safe, like if the noise is lesser than threshold value, green light will be turn on and buzzer stops. No tune, and the LCD displays it in LCD it will display like safe and noise is in control, and updates current noise level in like every 1 second. Working principles. Like in this working, what are the working principles? Like the microphone sensor detects the noise level. These microphone sensors, it will detect the noise levels. The in this by this Arduino, it will read the sensor values from 0 to 1023. From 0 to 1023, it will be reading the sensor values. And if the noise is above 600, the red LED turns on, buzzer sounds, and LCD shows an alert in the this. It will display that noise occurs. If the noise is below 600, the green LED turns on. Buzzer does not. If buzzer does not runs, the buzzer does not sounds. A buzzer stops and the LCD displays it's an safe. There is a no noise. The values are continuously updated for every 1 second or For every second, it will be updating the values in this LCD or through these sensors. Okay. These are the overview. This monitoring the real time. In this, we'll be monitoring the real time noise pollutions and alert users when the noise level is high, too high, and also display noise level on LCD, and provide a visual LED and Arduino buzzer warning system. These and all the noise pollution system. For now, we will be stimulating this. Will be start stimulating by clicking. See, as it has the range from 600 below 600, so it's the noise is safe and the noise is controlled. The noise level is 61. As it noise level increases, it will give an alert as high noise. The noise level is we will be notifying that the noise level is at 839. So as it increases noise level, it will be giving and it will display like alert like a high noise. Now as it noise level safe. As it noise level 471, which is below than the 600, the LED green light turns on and the noise is safe. And when it comes to the above 600, 696, the noise level like, it alerts like it gives an alerts like high noise, whereas red light will be displayed. Red light will be displayed. Okay. This is the noise pollution monitoring system. Thank you.